All right, we welcome you to lesson 15.2, volume of rectangular prisms, and you're going to find today's lessons probably a lot easier than some of the things we've been doing. And this is where you got to be careful because if you're not fully aware of each of these concepts, you're going to get confused when you see them in the future. So we just got done doing surface area, which is the space on the outside of a shape, and today is volume, which is space inside a three-dimensional shape. All right, so we started looking at 3D objects earlier this week with surface area. Now we're doing space inside. So surface area is not space inside. It was the space on the outside faces. All right, so very important to know. And this is where we're going to have 3 dimensions now in these type of problems, which you're going to see right here. All right, so let's look at this first example. All right, so this is one way to do it, is find out how many small cubes there are. So there's a couple different ways you can calculate it. You take a look at the edges right here, right? We have 1, 2, 3. And so that's 3 cubes right here. And then it's going over this way. So we have 3 right there, 3-dimensionally. And then we have another 3. And then we have another 3. All right. And then we have our different levels going up. All right. So we would have 9 on the first layer or floor, if you want to call it. Then we have 9 on the second. And then we have 9 on the top. So you would be adding 3 9s together, and we have 27. All right, so that's one way to do it. All right, be careful not to double count edges because some of you might be counting this edge and then this as different cubes. It's one 3-dimensional cube right there. It's kind of hard to see, right, with the way it's set up, but that is how a 3-dimensional cube would look underneath another one, and then you can't see the ones in the middle of the layers. You just have to assume they're there because these layers are full. All right, so one more example like that. All right, so here's another example of a stacked cube. Find 2 different ways to find the volume. All right, so we use the approach we just did. We find one layer. So we have 1 cube right there. There's another cube. So that's one little section right there. And then we have 2 of those. So we would have 2 and 2. All right, so there's 2 on each, or there's two layers of 4, right? So that's 4, and then that's 4. So we would have a total of 8. So that's one way to do it. And the other way you could do it is you could look at the columns straight up and down. All right, for some of you that might be a little bit easier, right? So if I was to cut it this way, straight down, all right, so this is a column and this is a column, and now I can just count it. 1, 2, 3, 4, make up right there, and then I have 2 of those together. So there's 4 there, and there's 4 there. So again, 10 square cubes on the inside. All right, so that's one way to do it. You can always count cubes. You're going to see in a moment that you're not always going to have cubes. So there's a formula now. So it's important to keep these straight. All right, and here we go. So the volume formula is length times width times height. So you're basically just timesing your 3 dimensions together, and this is where it comes from. All right, so right here you would have your base, right, which we've been calculating. So you find the area of the base, right, length times width. And then you think of it like as an elevator or like layers on a house. So, right, the H is the number of layers going up. So once you find the area of one floor, the H tells you how many floors up it goes. All right, so that is how you use the formula. The other way you see it sometimes is volume equals the area of the base times height, B times H. So you would have to find the area first. So when you're multiplying the 3 units together, what you're going to have is that cubic unit. All right, so depending on what it is, if it's cubic inches, you would put it like this, and it's going to be raised above to the 3rd power. So you'll see that here in just a moment. So let's look at some examples. All right, so let's calculate this. Let's find the volume of this shape. All right, so we have 3 times 2 1/4. All right, so there's a couple different ways you can do it. I would say for some of you guys, let's use decimals, right, because it's a little bit easier to calculate. All right, so 2.25 times 3. All right, so once you do that, 25 times 3 is 75, and you have 6. All right, so now we have 6.75 times 4.5. All right, so for purposes of our calculations, because we've been making some calculation errors, I understand that it's good to practice things, but if you want to use a calculator, that's completely fine, but you need to set it up like this first. And I think I was showing you guys this yesterday. You can get a Chrome extension now, And now you would type this in, 6.75 times 4.5, and then you have 30.375. All right, the other way you can do it is using fractions. All right, but you got to be careful on how you do it. Right, you have to change. We have to change that into improper fraction to multiply the parts, because you can't just do 3 times the 2 like some people would. They would just do 3 times 2 is a 6 and a 4th, and you have to multiply also by the fraction as well that added together. So that's why I say let's just go to decimals here, and let's make it as simple as possible. And then, whoops, lastly, I need to have my cubic meters. Next example. All right, we have, find the volume of this figure right here. So we have 7.5, 4, and 2.5. So if I'm going to start with my base, find the area of my base first, I have 7.5 times 4. All right, I can do this one without a calculator, all right, since it's just a one factor multiplication. All right, so I'm going to bring the 2, add it. So now I have 30. All right, so 30 is my base, 30 square inches, and so that's 1 floor, and now I'm going up by 2.5. All right, so 2.5, you can use your calculator. This is a cool way to do it. When you have a 0, right, you can put the 0 on the bottom, so it makes it a one factor multiplication problem, and then you put the other factor on top. Then you're going to have to adjust for your decimal, but here we go. You bring down the 0, right? 3 times 5 is 15. Carry the 1. 2 times 3 plus 1 is 7. All right, so be careful. We have the 1 digit after, so I need to match it now. So 75 cubic inches is my answer. And again, you could pull out the old calculator, but you have to at least show what you're doing when you're doing this. 7.5 times 4 times 2.5, and there we go. All right, and the other way you're going to see these examples are this way. So you're going to just be given the length, the width, and the height. And so you can calculate the base first, so times these two together, and then you multiply that product by the height. All right, so length times width times height of your shape. All right, and then the last type here, there's another one, a little word problem type. All right, so you're going to be given a type of problem that has 3 dimensions. So here we have a swimming pool. All right, so you could draft it if you wanted to, and you can just label your sides in. It's 15 meters long. It's 10.5 meters wide. Now this is a little bit tougher to show, right? Because depth, I can't really show depth right now because of the way that I set it up. So what I could do is go this way with it, but now it's not really a swimming pool. It's kind of standing up, but you get the idea. That's where my depth is coming from right now. And then we just rotate my pool down. So 2.5 is here. All right, regardless of how you look at it, you have your 3 dimensions. And so you're going to multiply them again. And once you do that, I'll use my calculator here, 15 times 10.5 times 2.5. So 393. I didn't catch that last part, and it doesn't save my answers, unfortunately. So don't make the mistake I do. So one more time, sorry, 15 times 10.5 times 2.5. All right, so my decimal is 0.75, 3/4 as a fraction. Now I need my unit, meters cubic. All right, so be careful again to not make simple mistakes when you're setting things up. All right, eventually after we get used to calculating these formulas, I'm going to put some surface area versus volume problems together on the next assignment. So you guys are going to have to decide which type of problem it is. All right, so again, volume is space on the inside. So a swimming pool, the water would go inside the 3 dimensions, right? And then if this is a prism and you're painting the outside, that's surface areas where we found all the faces and we added them all together. All right, so you have to know what you're doing in terms of the question type. We'll start easy, so a day of computation, and then we'll get to our word problems, and then we'll get to surface area versus volume as well. Any questions, let me know. But again, set up, show me what you're multiplying together. If you want to use a calculator, that's fine.